Unit 8, Coulomb's Law. Anybody remember what Coulomb's Law is? F equals K Q Q over
R squared.
R squared. Woo. You can call them Q1 and Q2, or you can just write QQ. But the thing is, you need to know that the two Q's are not the same charge. If they were the same charge, we just write Q squared, right?
Yes.
So there's two different charges. You can call it Q1, Q2. You can call it QA, QB. You can call it Q smiley face, Q frowny face. I don't care. Okay? But just know that the Q's are different charges. Right? So Q and Q, these are two charges. And what was the units on these charges? Coulombs. Big C. Named after Charles Coulomb.
I was about to say Joseph again.
There we go. Okay. R is the radius.
Why did they call it CC then?
That's cubic centimeters. Different.
Is it?
F is
What do you got there?
force.
When was this guy alive?
I think 17 or 1800s.
Is it for cubic?
Yeah, it was before they started doing dirt bikes.
So why did he say it? Did it should have CC said?
I don't know. All right. Julian, pay attention, please. Okay. And K is a constant.
What does that mean?
Means it's always 9 times 10 to the 9th.
Okay.
And it's newtons times meters squared per coulomb squared. Because newtons are in forces in newtons, and radius has to be in meters. Right? So that's Coulomb's law. We introduced it to ourselves yesterday. Now we're going to have some practice with it. Are there any questions about Coulomb's law before we move on? Any questions about the equation? It looks just like the gravity one, right? Constant times two masses over radius, right? Constant times 2 charges over radius. So it's very similar to the gravity one. Okay. Maybe Newton and Coulomb are buddies. Maybe.
Maybe they shared.
Maybe they
Although I don't think Newton had a lot of friends. Okay. So, what does Coulomb's law tell us? What does Coulomb's law tell us?
Stuff about electrons.
Stuff about electrons. Richard? Good. Tells us the force felt between 2 charges. Okay. Now, do the charges have to be equal charge to feel the same force? No. There's just one equation, right? Right? Just like there's one gravity equation. So since there's only one equation, that means the force felt by both charges in this equation is the same. Right? What law is that? Third law. Okay. Q1 pushes on Q2 with equal and opposite forces. Q2 pushes on Q1. Just how it works out. You've got the other laws? Okay. So, one thing I should mention before we get into some practice problems is something called the elementary charge.
Elementary or elementary?
Elementary charge.
Like little kids?
Yes. Okay. Elementary charges are 1 electron or 1 proton. Okay. The charge on 1 electron is 1.6 times 10 to the negative 19 coulombs. Okay. And electrons are said to be negative. Okay. So if that's the charge on an electron, what's the charge on a proton?
Same thing, just positive.
The same thing, just positive.
So it'd be 1.6 times 10 to the 19.
Yep.
Oh, so negative 19.
Yep, still negative 19. Just this number right here is not negative. Okay? Guys, the exponent is still negative because the exponent being negative means that the number is less than 1. Right? So the number is less than 1. So the exponent is still negative, but the sign in front of the 1.6 is positive. Okay, does that make sense? If I change this 19 to a positive 19, that makes this number really big. Right? This number is really small. Now, I know we talked a little bit about lightning yesterday. We kind of had a storm. The way lightning works is there is an abundance of electrons on a cloud. Do those electrons like to be on the clouds? No. Okay. So the lightning will jump to the closest thing it can reach. Now, as lightnings go over tall buildings, they usually strike the tall buildings because that's a shorter distance for the electrons to jump. It requires less electrons to jump that distance. Okay? If the lightning goes to the ground, it needs more electrons. That's why lightning tends to strike taller objects, or taller objects get struck more often, because it takes less electrons to jump, and it's a shorter path to what the electrons see as a neutral object. Yes, Sergio?
So, fogs are like clouds? Are fogs like clouds?
Cloud is like fog, yes.
Okay, so like...
Why don't we get electrons in, or why don't we get lightning in fog?
Electrons in fogs?
Yes.
Could anything like that happen?
No.
Why?
Because the fog is so close to the ground, it doesn't require a lot of electrons to jump. The lightning would be about as strong as the lightning that goes from your finger to the doorknob when you drag your foot on the floor. And touch the doorknob. Okay. Because the fog is on the surface. Okay. Fog is a cloud on the surface of the earth. Yes.
So, if you were like negatively charged, would the lightning still strike you or not?
No.
So like it would just go around you.
Yep.
Oh.
Would be repelled by you. So, what lightning strikes, the reason I bring it up, is lightning strikes is between 5 to 25 coulombs. Okay. 1 electron is 1.6 times 10 to the negative 19 coulombs. Right? Mm-hmm. So that means 5 coulombs of charge. We divide that by 1.6 times 10 to the negative 19. Right? We get the number of electrons in a small lightning bolt. Right? So you take out your calculators and do 5 divided by 1.6 times 10 to the negative 19, and that's how many electrons we have in a small bolt of lightning. Okay. Is it going to be a big number or a small number? Big or small? Won't be a little one. Be a big number. Okay. So it's 3.125 times 10 to the 19. Okay. So that's 3.125 followed by 16 zeros. All right, that's a lot of electrons. Okay, big lightning bolts. They said between 5 and 25. Multiply that by 5. So multiply that by 5, and it's 1.5 times 10 to the 20 electrons. Okay, not much bigger. There's by the order to magnitude of 10 bigger. Right? It's like the difference between 3 and 15. Okay. Any questions about lightning, Coulomb's law, charges? Anything?
Mr. Branch,
Yes.
for the unit, is it a capital C or is it a small c?
Capital C. These are coulombs. These are electrons.
Okay.
So yeah, these C's right here I should make them capital. I'm sorry. Anyone else? Okay. Let's say I have 2 protons. And these 2 protons are going to be separated by 0.1 meters. Okay. Can we find the force exerted on each proton? Well, if I have a proton, what's my Q1? What's Q1 for a proton? Good. So one of my Q's will be 1.6 times 10 to the negative 19. The other Q will be the same thing. The radius is 0.1 meters. Right? So can we find the force? Yeah. We know K is always 9 times 10 to the 9. A little bit easier to remember than 6.67 times 10 to the negative 30. No. You remember that? Okay. QQ over R squared. 6.67 times 10 to the negative 16? 13? Goodness. 31st? 31st. I'm mad at myself and I remember what big G is. 11! I'm done. Okay. Alright, so we can plug in what we know, right? So 9 times 10 to the 9th times 1.6 times 10 to the negative 19 times 1.6 times 10 to the negative 19 all over 0.1 squared. Now, when you're doing these, when you have 10 to the negative 19th, you do 1.6 e negative 19. Okay? 1.6 e negative 19. So we can figure out this force. So 9e9 times 1.6 e negative 19 times 1.6 e negative 19 divided by 0.1 squared. What's the force? Akira? Yes, that's fine. What's the force? Am I the only one doing it? Oh my goodness. It's like going to an ice cream shop and not bringing a spoon.
But they have cones.
They supply
Never
those
know.
actually.
They have cones.
Alright.
That was a word.
Wait, why would you bring some
Just in case they're out.
That was like eating a taco without the.
Without the shell.
Yeah, there you go.
There we go.
Without the tortilla.
It's like having a tamale without cornmeal, right? Big force or little force? Big force or little force? Little. Okay? That's 0.25 zeros, 2.3 or 2304. Okay. What?
I got negative 30.
Because they're two protons. You got negative 30. Did you square your 0.1?
Yes, I swear about that.
Oh, I thought it was a negative. Oh, that's what I thought.
What?
I am.
Because it's a really small number. Yep. We're talking about protons and electrons. All right. Any questions about that? Any questions? So which way is the force felt? Yes.
So K is always going to be.
Yep. It's a constant. It means it's always 9 times 10 to the 9. Okay. Anyone else? Good question. So which way is the force? They towards each other away. Come on, be smart about this, right? This is positive. You might think they both go to the right, they both go to the left. We said yesterday, positive means they push
Away.
away. Okay, has anyone ever seen a polar graph before?
No.
Polar coordinates.
The Polar Express.
Okay. Instead of graphing in an x, y, you graph in a circle with radiuses and angles.
That's confusing.
Okay? There's no negatives.
Like a
Right? Positive radius means you move away from the center. Negative radius means you move towards the center. Okay? This R stands for radius. So if I have a positive force, that means I'm moving away from the center. Okay? So these are my two protons. The center is right there in the middle of the two. Okay? Positive force means they both feel a force away. Okay? Does that make sense? Yeah, does that make sense? Okay. Now, how does this problem change if I switch these to electrons?
It's the same.
If I switch those to electrons. Are their forces still away? Okay, but I'm going to have a negative number, aren't I?
No. It's negative.
Ah, good. If it's an electron, then we have two negatives, right? Right? The two negatives still make the force positive, which means the force is still the same. The force is still away from the center. Okay, does that make sense, guys?
Yes.
Yeah? Okay, any questions? Positive means we're pushing away from the center, in between the middle of the charges. Negative means we're pushing towards the middle of the charges. Okay? Does that make sense?
Yeah.
Let's try another one. Let's say I have 2 protons and 1 electron. And they're going to be separated by 30 millimeters. Okay? 2 protons and 1 electron, and we're going to be separated by 30 millimeters. 30 millimeters. So I got to turn millimeters into meters, right? So we know 1 millimeter is 1 times 10 to the third meters. So 30 divided by 1 times 10 to the third. Move the decimal place 3 spots. 1, 2, 3. 0.03 meters. So you're almost there. You're doing centi. Okay. So 0.03 meters. What's Q1? We can call it 2 protons, right? I can also call it 1 electron. 2 protons. That means I have 2 of the 1.6 times 10 to the negative 19s, right? So, nope. So I have 2 times 1.6 times 10 to the negative 19. That's 2 protons, right? So that's 3.2 times 10 to the negative 19. Q2 is 1 electron, right? Right? 1 electron is 1.6 times 10 to the negative 19. Negative. And K is always what, Kevin? 9 times 10 to the 9. Even with your face in the table, you can still pick that up. Nice job, bud. Yeah? You need to stand up? Yep. So then we can find the force. Okay? So to find the force, we still use Coulomb's laws, same way as we did in the previous one. F equals K Q over R squared. So we can plug in 9 times 10 to the 9th times 3.2 times 10 to the negative 19 times 1.6 times 10 to the negative 19 all over 0.03 squared.
So negative 19?
Yep.
Golly. I thought you said they'd be small numbers.
They are small numbers. Negative 19th means we're less than 0.
Well, I didn't think you meant, like, I thought you meant single digits.
Gotcha. Okay, so what do we get for our force?
I got 4.6 times 10 to the negative 28. Oh, wait, I forgot to divide.
Isn't that supposed to be negative?
Yes, it is negative. Thank you.
Okay, now I got 5.12 times 10 to the negative 25.
Don't forget the negative on the electron, guys.
I don't know, negative.
You heard?
Yep. Is it positive or negative? Negative. Okay. So, the force is a negative 5.12 times 10 to the negative 25th newtons, right? So, is this force toward the charges or away? Towards. So this force is towards each other because it's negative. It's towards the center of the charges. Does that make sense?
Yes.
Now, which one feels a bigger force? The protons? You think so? Because there's 2 of them, right? Is that right? Nope. They're equal. They're equal. There's only one equation, right? Only one equation. That means the force is equal. Okay? The force is the same. Right? You can think about it this way. 2 protons here. one electron, right? Right? The electron pulls on each proton with a little bit towards it, right? The protons also pull on the electron, right? Right? So this proton pulls on this electron with an equal force. That proton pulls on this electron with an equal force, right? But these two protons are together, aren't they? Right? So since those two protons are together, like in the nucleus of an atom, that means that the protons are feeling the same force as the electron. Okay? Does that make sense? Okay. Are there any questions? Any questions?